Now we will review everything you've learned so far in level 3. So first, static, which you actually learned near the end of level 2, which is basically means that you do not need an object. So basically, for example, static variable means that, well, a variable owned by the class, so you do not need an instance of the class, basically an object. Basically, because the variable is owned by the class, you can access it by basically class name dot variable name. And then a static method is basically a method owned by the class. You do not need an instance of the class or an object, so accessed by class name dot method name and then the arguments. Next, instance, on the other hand, which by the way is not a keyword. So static means that static is a keyword, which means basically all static methods have static in their header. All static variables have static. However, instance is not a keyword, so basically instance variables and methods don't have the word instance in their header or definition. So an instance means that, or instance variables and methods means that you do need an object. So basically, well, first, an instance of a class is an object of the basically of the class, of the type class. So basically an object. So an instance of, say, class name is an object with type class name. Now, there's also instance, like instance methods and instance variables. So instance methods and instance variables. Variables, instance variables, basically means you need an instance, which is an object, to access. Otherwise, the variable doesn't even exist. So basically, for example, accessed by object dot variable name, where the object could be a variable, it could be an expression, like for example just directly calling the constructor and calling the variable name. It could be an element of an array, it could be a parameter, it could be anything like that. It could be what a method returns anyway. Basically, at least some sort of object. And then instance methods, you need an instance to access as well. So accessed by object, whatever expression you have here, dot method name, and then the arguments. And by the way, what's the difference between an argument and a parameter? Well, an argument or a actual parameter or an actual argument is basically what you pass into the method. And a parameter, also known as a formal parameter or a formal argument, is basically the variable defined in the header of the method. Sometimes this vocabulary can be like quite ambiguous, but just know in general this is the type of vocabulary. So next, onto stuff that's purely level 3. So inheritance basically means a relationship between classes, basically an is a relationship between classes. So an A is a B if A extends B. Basically, in other words, so if A extends B, then A is a special case of B. So, in other words, every A is a B. However, not every B is an A. And then extends, which by the way is a keyword used in inheritance, basically the keyword used for inheritance relationship. And extends, basically if A extends B, then A is a special case of B. And also a class should not extend itself, nor should we have loops like X extends Y, Y extends X. That's bad as well. Next, there's the super, which is also a keyword. It's a keyword used to access variables, methods, or say constructors of superclasses. And actually variables are barely used for this. So it's a keyword used to access methods or constructors of superclasses mainly. Where super.method name with arguments calls the superclass method name, and super without any dot or anything like that, just plain super with arguments, calls the superclass constructor. And notice that super needs to be the first statement. In other words, no statement can be before it. This also implies that there can be at most one super call. And also, if there is no super call, then the default superclass constructor is called, basically the one with no parameters, and if that doesn't exist, then there's an error. Compilation error, basically. Overriding methods is basically, by the way, none of these are keywords, basically means that we have a method in the subclass that is basically has the same name, parameter types, and return types as the superclass method. So if it's the same name but different parameter types, it's not overriding. If it's a different name but the same parameter types, it's not overriding. And if it's the same name, same parameter types, it must have the same return type. Otherwise, there's a compilation error. And of course, you can do super dot method name with arguments if you need to call the superclass method. Next, casting, which by the way is not a keyword, is basically converting a type to another. Casting can only be between superclasses and subclasses. So you can cast either way, but you can't cast from string to scanner. That's dumb. And casting only takes care of runtime errors. And remember that Java only cares about actual types in runtime and only variable types during compile time. So basically, so improper casting will result in an error. Also, if we have a subclass, so superclass variable s1 equals new subclass or something like that, then s1 dot method will call the subclass method, because in runtime only the actual type matters. On to instance of, this is basically an operator that checks whether an object is an instance of a class. So basically, new A will always be an instance of A, and new B is an instance of A if B extends A directly or indirectly or implements. So then next, null, which is technically a value, so it's not a keyword, but it's basically a keyword because you can't use it, is basically signifying a variable, usually used for a variable that has no object and cannot be used for primitive data types. And also, when printed, it prints literally null. And if you try to access variables or methods, it will cause a runtime error. The ToString method, again, definitely not a keyword. It's just a method and object that should return a string to be printed. And basically, well, if you want to be able to print an object, you should override the ToString method. Equals should return whether values are equal. Basically, for example, the string equals method does that. It checks the values. String 1 dot equals string 2 returns true if and only if they are equal in value. Next, public means accessible to everyone. So public variable or method. And then public class is way different. That's not the type of public. It's not the same type of public. Public variables and methods are accessible to everyone. Public classes are just the main or primary class in a source file, basically a .java file, basically what we're programming in right now. Private means accessible to the class itself only, so not even subclasses can see it. And external classes can definitely not see it. Next, abstract. So abstract can refer to abstract class, or at first let's do abstract method, which is a method with no body that must be overridden in all non-abstract subclasses, and where an abstract class, on the other hand, a class that may contain abstract methods. So a few things about the abstract class: you don't need abstract methods, but there's no purpose to making it abstract usually if you don't have them. Also, you can have normal methods, variables, and constructors. However, a warning with the constructors is basically you cannot create an instance of an abstract class directly. You must do it through a subclass. That's the only use of an abstract class. So the constructors are only used so that the subclasses can call super. And then, obviously, there's no such thing as an abstract variable. Because if you think about it, that just doesn't make sense. Next, an interface is basically something that can only contain public abstract methods and constants. So before that, actually, alright, so another thing to note is that abstract methods cannot be private, because that ruins the entire point of them being overridden, because you can't overwrite private methods. So an interface can only contain public abstract methods and constants. So basically you cannot have private, default, or protected abstract methods in an interface. And of course these methods must be overridden in non-abstract classes that implement this. And then, of course, implements, basically keyword used to show that a class uses an interface. So first of all, a class can only extend one class, but it can implement multiple interfaces. You just need to separate the classes by interfaces by commas. You can both also extend one class and then implement interfaces. That's also allowed. Another thing, interfaces don't implement interfaces. They can extend interfaces, however. And all that does is basically it inherits the methods. And interfaces never extend classes. They don't even extend object. And also, you cannot create a direct instance of an interface. You must do it through a class that implements the interface. And lastly, interfaces can contain constants, which means to get what constants are, there's the final keyword. So final keyword can be used in, first of all, variables. Basically, final variables are constants that cannot be changed once initialized. So basically, that's what constants are. Of course, in an interface, by the way, you do not need to specify public, abstract, or final in an interface, because the interface directly does it. Next, final methods are not constants. They're just methods that cannot be overridden. And finally, final classes are classes that cannot be extended. One last thing to note is that abstract methods are always instance methods. So basically you cannot have static abstract methods. Because if you think about it, static methods don't really like have in purpose for inheritance, but really though, abstract methods are all for inheritance. So there's no purpose for static abstract methods. So you cannot create a static abstract method. That'll be an error, just like private abstract method. Similarly, an interface cannot have static methods because they only contain public abstract methods.